Welcome. Let's look at inequalities that will require multiple steps. And then we're also going to look at a couple of variations of these too. So, what we want to do anytime that the directions involve solving, that means we want to get x equals or x greater than or x less than or equal signs with those if needed. But that means the x by itself. We want to isolate it, find out what number or numbers can be acceptable as x, or to replace x. That means in most of these, we have to get these on the same side. So I'm going to subtract 2x from both sides so that I get them together here. Okay. Now I'm going to put the numbers together. Because this made 0 here, this makes 0 here. So what we're down to is x is less than or equal to number 9. And there, that's one of our answer to that one. Pretty simple, pretty straightforward, actually. Now, when we look at the next one, don't write this down if you're taking notes, but if I do minus 6x and minus 6x, I'm going to get a minus 4x. Nothing wrong with that whatsoever. But I can avoid dealing with a negative x value or number by moving the 2x over to the other side. So this would become 0. I get negative 13 is less than or equal to 6 take away 2 is 4x plus 17. Now I would isolate the x by combining the numbers. So this is actually the first thing we're doing for combining like terms. Minus 17, minus 17. So combining like terms. So here I get negative 30 less than or equal to the 4x. So I'm now going to divide by the 4, and I get x greater than or equal to, what goes into 37 times and half left over, so that's actually negative 7.5. Okay, now let's point out something here. Is that we don't usually leave our variable on the right side. It's perfectly okay to do so, but it's not comfortable for most people. So we're going to change this by putting the x on the left side, and that's perfectly fine as long as you keep the inequality sign in the same relationship to the x as it was. So right here, right now, this is saying the x greater than something, greater than or equal to something. It has to say the same thing as we switch it. So that means we switched this one and made sure the inequality said the same thing that it did here. X is greater than or equal to negative 75. Okay. So this was the dividing by 4 part. So it's all isolating the x. Now let me point out something. Back up here, let's say I had gone and done the 6x move first. That would have been perfectly fine. 6x, because we would have gotten negative 4x minus 13 less than 17. Add the 13 to both sides. 30. Now divide by the negative 4 and we get x, but we also get reversing the inequality sign. And then we get, so that's a negative there, we get negative 7.5. So we get the same answer. Now, something about this is that if you wanted to, you could have started with the adding 13 on both sides as your first step, and then do the x's. Perfectly fine, too. You could have done that first, and you would not have hurt this at all in a way. Okay. Good, it is not. So now let's go to the next step where we're actually going to do some prior work before we can isolate the x. And that is to multiply or distribute 6 in here. And you can do the same thing over in a problem like this, even though the x is not the first term. But first, we'll do this one. That's 30x minus 18 plus 2x plus 4 greater than 36x. Now, there is an error that sometimes people make with this, and so I'm going to show that. Here we have a plus 2x and a 30x. Do not do this, don't write this down, but just think about it. What sometimes happens is people look at these, they're so used to x's only being on the other sides that they try to subtract 2x to make that 0 and subtract 2x here. But you can't do that because they're not with an equal sign. In fact, I'm going to now erase it so that you know that instead what you do is simply combine these as like terms. Now, you don't need to do it this way. What I'm going to do is the official math thing, which in this case here is the commutative property. I'm going to switch them. And I'm allowed to do that as long as I keep the minus sign in front of the 18 and the plus sign in front of the 2x. Next, I'm going to combine the like terms. 32x minus, oh, and I should have finished this problem with the rest of that. Now, negative 18 plus 4 is negative 14. That's the kind of thing you want to watch, that you can do that. Because now it becomes like these other problems up here. In fact, we don't even have the numbers on both sides. So you can get nothing wrong with that. I am going to do this one. I'm going to subtract 32x here. So that becomes 0. And as I'm dividing these, so I have negative 14 greater than negative 4x. Now, just because I like it that way, I'm simply going to turn these around, but I'm going to keep the same relationship. And now I will divide by negative 4. Sides divide by negative 4, both sides. And that means x, and switch the inequality. Turns up back the way it was, but for a different reason now. Okay, so these go away. Here, the negatives go away, and we have 14 over 4. Let's see. We get oh, hold on a second. 36. I'm subtracting 32 from it, so it's actually a positive 4 here. Okay, so hold on. Let's go back. I have a problem, and I'm glad I caught it fast. Not quite fast enough, but I caught it here. So this means, and I won't want to mislead people by putting that, let's not put what looks like a division sign. So the step in red is I'm subtracting 32x from both sides. That means that this is plus 4x here. Now I'll divide by 4, which means I do not need to reverse the inequality sign. Oh, and I get, let's divide by plus 4. And that allows me to get negative 3.5 greater than x. And I want to reverse it because I like having the x on the left side, but I keep the relationship towards the x the same. In this case, x is less than, and it is less than even if we switch it around. So even though we get a negative as a result of the number here, that's not saying that we reverse the inequality sign, and that's because when we divided by the number 4, positive 4. Okay. Let's look at the other problem here. And I'm going to, I'll use black this time with it. I'll multiply into these, so I have negative 2x plus 1 greater than or equal to 6x plus 6 minus 3x. So I need to combine these like terms combine. So I have negative 2x plus 1 greater than or equal to 3x plus 6. 6 of the x's take away 3 of the x's is a 3x. Now I want to put these together, and this time I'm just simply going to move these over to the other side and subtract 3x from both sides. So I get negative 5x plus 1 greater than or equal to 6. Subtract that 1. So it's negative 5x is greater than 5. And now I'm going to divide by the negative 5. But this time it is real and right that I do, and I get just the x. And I have to reverse the inequality sign. Make that a little too long. And here I'm dividing by a negative 5. Whoops. So 5 divided by 5 is 1. But with the negative, it makes it negative 1. So its x is less than or equal to negative 1. Okay, so there's a lot of steps in there. That's why I have to keep track of each thing. So here on this one, it was combine. And, actually, first step was to distribution. Second step was to combine like terms. Third step, subtracting 3x. Fourth step, subtracting the negative 1. Fifth step is dividing by the negative 5. Quite a few steps in that. You have to show them in order to get the correct answer. Be right on. Now, we're going to look at variations. These two illustrate that when you boil it all down, it comes to simply x is less than or equal to, or it could be greater and greater than or equal to, whatever. And so you get what is we consider a normal answer on there. But on the next page, it's a little different. We're going to look at no solution or infinitely many solutions. You can use a null set symbol to illustrate it, or an old real number symbol. Or we say the words no solution, infinitely many solutions, which right now is preferable. Watch what happens here with these. I'm going to choose to do the numbers this time. I'm going to do plus 9. So I get 2x greater than or equal to 2x plus 10. Now I'm going to subtract 2x from here so I can get it out of the way of that side. And I subtract 2x here, and I get x is greater than or equal to 10. But that's not true. Not x, I shouldn't have said 0. 0 less than or equal, 0 is not less than 10, it's not equal to. Or greater. Okay, excuse how I said it. This is showing greater than. 0 is greater than 10. That's not true. So if it is a false statement, that means we say no solution. If I had done the x's first, let's say I had done that first instead, 2x minus 9 greater than or equal to 2x plus 1. So let's say I subtracted the 2x's first and I get negative 9 greater than or equal to 1. Here, negative 9 is not greater than 1, it's less than, and certainly not equal to. So it'd still be this no solution. Because it's not possible. There's no x value you can put in there for both of those at the same time that will give you an answer that is correct. If I put 0 in as an example, I would get negative 9 is greater than 1. Not equal to 1. Negative 9 is not greater than 1. It's less than. So we'd say no solution. Okay. So false here or false here. False, false. Now, on the next one, it's actually just doing a whole bunch of prior work before you get it down to a no solution or a solution or other options. So let's actually just work this out. These and those, I'm going to get the negative 7x minus 28 plus 11x I'm going to get the, oops, need to write the actual greater than or equal to sign, 8x minus 4x minus 2. There. Now, on each side, combine like terms. So we have here negative 28 plus 4x. So negative 7x plus 11x is plus 4x. Greater than or equal to, well, combining these two gives us a 4x minus 2. I see the x's are the same. Let's go ahead and subtract 4x from both sides. And what we get is negative 28 greater than or equal to negative 2. So this one again is not true. Negative 28 is less than negative 2, not greater. So that means we call it false, and we write no solution. Now back up here to this null set. The idea of a null set is that the set of answers is empty. We sometimes show the possible answers inside these kinds of brackets. So, or we have a 0 with a line through it also means null set. But this is best way to put it. Best way to give the answer. Okay. On the other one's really straightforward too. Now let's look at the opposite. This is when there is no number that can go into these two x's places, none whatsoever, that will give you an answer that's correct here. Okay. On either one of these examples. This one's different. It's basically saying any number of x will make this a true statement. Well, let's look it up and let's see what happens. That's 46 greater than or equal to. Oh, hold on, excuse me. I'm trying to not mean for that to go away. Oh, we just lost it. I'm so sorry. Let's go back and reopen this. And I'll start that problem over again. Oh, some stayed here. Well, the null set ones did not, but we were just starting this one, so let's go ahead and do that. Do remember that these were no solution problems, but here infinitely many solution problems. Let's work this out. 46 greater than or equal to 8x, and then we're multiplying these in here as negative 8x minus 20. 46 is greater than, well, 8x, take away 8x is 0, it's gone. Okay, but here 46 is greater than negative 20. This is a true statement. And when it's a true statement, we say that the answer is infinitely many solutions. And that's the textbook answer for it. So that's what I want you to do. Saying infinite solutions can be acceptable. So that makes sense, and that's okay. All real numbers is also a correct way of putting it, which can also be shown as the R with a double lines. That's another way of showing it. So although these other three are acceptable, I would prefer that the answer be given this way. That's infinitely many solutions. And if you do this one, it'll be okay, but I prefer not to put all real numbers right now. I prefer to say infinite solutions. I want to make sure I have an S in that. Now let's look at this next problem and we'll see the same type of thing. So that's 6 minus 3x less than or equal to 10. And let's multiply that in here. Negative 3x And negative times negative is positive, so it's plus 6. And so I immediately see that on the right side I should be combining some terms. 10 plus 6 is 16 minus 3x. Oh, well, the x's are the same, so let's go ahead and do the plus 3x on both. We make that 0, but also go here. So we get on this is 6 is less than or equal to 16. Well, it's not equal to, but it is less than. So therefore, this is true. And that means we say infinite solutions. Back up there, this one, remember what happened here was this came to negative 9 greater than or equal to 1, or we would have gotten 0 greater than or equal to 10, both of which are false. And when it's false, we say no solution. And over here, same thing. We work this out. We're going to get negative 28 greater than or equal to negative 2, which is not true. That's not a true statement. So therefore, we would say no solution. Okay. So this page shows the variations that can come, or exceptions, sort of. This is when there is no possible answer for x. And this is where any number for x will make it good. Say infinitely many solutions. And back on the first page is where you see normal ones that don't have those variations, just quite a lot of steps to do. So practice those, pay attention to them, look for the clues of like being on both sides or with or without variables. Well, thank you for watching. I hope that does help for doing these things with the multi-step and inequalities. Thank you for watching and listening.